Hey guys, in this video we're going to be covering Key Concept 2. So you can look at those old note packets, activity packets, even the test review, and the hints are at the end or next to every question. So looking at our first question here, number 11, it says state the domain. So hopefully you remember that domain is all the possible x values, and that's going to be from our negative infinity all the way to our positive infinity. And that is what we are going to write for our domain. Negative infinity to positive infinity. Our range are all the possible y values. So what you're going to actually start at is the vertex, and you're going to figure out whatever that y value is. This y value is -4. And from -4, this parabola opens upward to a positive infinity. So it's going to be comma, positive infinity. Identify our x-intercept. So x-intercepts is wherever we're intercepting the x-axis, and our x-intercepts are right here and right here. So you can write those as x equals -1 and x equals 3. If you want to write them as ordered pairs, you could also write them as -1, 0 and 3, 0. Do not write them as -1, 3 because that is a different order pair. So write them individually. Target 2b, adding, subtracting, and multiplying. When we are subtracting, one of the biggest things is we know we're subtracting because that negative sign here, that's going to distribute to everything after it. Alright, so our first parabola does not change, so we can actually just bring that down. So 9x squared plus 8x. Now this is where it changes, because negative times a positive is going to give me a -6x squared. A -1 times a positive 4x is going to give me a -4x. A negative times a -10 is going to give me a +10. Now from here we can just combine our like terms. So remember they have to have the same variable, same base, same exponent. So in this case 9x squared and a -6x squared are like, so 9 minus 6 is going to give me 3x squared. What other ones are alike? We have a positive 8x and a -4x. So positive 8 minus 4 is going to give me a positive 4x. And then our last term here, we don't have anything else to combine with it, so we just see that constant on its own. Don't forget to bring it down. Right, so that is going to be our final answer. When we multiply, those of you that use FOIL, you may FOIL. Otherwise, I'm going to show you how to do Punnett square boxes. Remembering that each binomial has to be on its own side. Doesn't matter where you have it, as long as each term stays together. So when we have to keep each of those terms together, my 11y is going to stay together with that +3. My 2y is going to be on the other side with that -4. Also bring the signs with it. So now we just multiply. 2y times 11y is 22y squared. 2y times a +3 is going to be a +6y. 11y minus, or times a -4 is going to be a -44y. A -4 times a +3 is a -12. So now we want to go ahead and write all those terms out on the side. So I have 22y squared, a +6y, a -44y, and a -12. From here I combine like terms. I'm looking at, I know it has to be in standard form, so I only see my one term that has y to the second power. There's no other y squareds. Then move to the next term. I do see two like terms right here, a +6y and a -44y. That's going to give me a -38y. And then my last term here, I don't see any other constants, so I'm just going to bring down that -12. There's nothing else to combine with it. Right, next example, it does say to multiply. Here we have two variables, but the steps are exactly the same. Remember that if something is being squared, all that is telling you is that you are multiplying it 2 times by itself. So we're going to have a c plus d on one side and a c plus d on the other side. when we're multiplying these out, c times c is c squared. C times d, keep it in alphabetical order, so CD. C times d, again, is CD, keep it in alphabetical order, and d times d is d squared. Remember, alphabetical order. Nice. Alright, so now we just write all those terms out. So c squared plus cd plus another cd plus d squared. So my like terms here, I only have one value variable, that is a c squared. I do have two cd's, and just the way I said it, I have two cd's, right? There's one coefficient of 1, coefficient of 1. So when I add those together, I get 2 cd. Last one, there's no other d squared, so I just bring my d squared down. Alright, this brings us to target C. Here it says factor the quadratic expression. We have your factor chart, so please reference that if you need to. We're looking for values that multiply. We want to multiply to that negative 12, but we want to add to a positive 4. So what number is going to multiply to a negative 12 but add to a positive 4? So again, you can use your Punnett square boxes. We know I'm going to have my x squared in the top left, my negative 12 in the bottom right. So numbers that multiply to a negative 12 but add to a positive 4 are going to be, we have a positive 6 times a negative 2. Right, that's going to give us our negative 12. If we have a positive 6 minus 2, that's going to give us a positive 4, which is what we need. So the two numbers that I'm going to put on the side are going to be a positive 6x and a negative 2x. Alright, figuring out what the outsides are going to be. This is going to be x times x. This is going to be x times a positive 6. This is going to be x times a negative 2. So my two factors are going to be x plus 6 and x minus 2. I don't care which order they are in, as long as that's still all equal to 0. As long as you have both sides. Alright, so remember, multiplying to the last term, adding to the middle term. Number 18, factor and solve. If you notice, this is a difference of squares. So what you could do is you can take the square root of each term. Right, taking the square root of x squared is going to give me x. Taking the square root of a 121 is going to give me a positive or a negative 11. So when I write these two factors, I know I'm going to have a positive 11 and a negative 11. Still all equal to 0. So that was just the factor part. But if it's asking you to and solve for x, you have to set each of these equal to 0. So this binomial is going to be equal to a negative 11, and this one is going to equal to a positive 11. Remember, take the opposite. Don't forget to solve for the x. The next one, we have 3x squared plus 27x plus 42. Before I even get to factoring, one of the things is look to see if there's a GCF. So there is a GCF in this example. Our GCF is going to be 3. So I'm going to divide a 3 out of every single term. So that's going to give me an x squared. Divide 27 by 3, it's going to be a positive 9x. Divide 42 by 3, and that's going to give me a positive 14. Still all equal to 0. So now just like above, this is the number we multiply to. This is the number we multiply to, and this is the number we add to. So what numbers are going to multiply to a positive 14, add to a positive 9? You need to do your Punnett square box. Alright, this is going to be an x squared. This is going to be a positive 14. Two numbers that multiply, we need to multiply to a positive 14. And when we add them together, we need to have a positive 9. So two numbers would be 9 and 2. Not 9 and 2, 7 and 2. 7 times 2 is 14, and 7x plus 2x would me that 9x. So I'm going to go ahead and put that 7x and a positive 2x here in my diagonals, which would give my Punnett square box the outsides reading x plus 7 and x plus 2. So those are my factors. Can't forget to bring that GCF down. So x plus 7 times my x plus 2, still all equal to 0. Hopefully remember that the directions did tell us to solve for x. So setting each of these equal to 0, x is going to equal -7, and x is going to equal a -2. Don't forget to actually answer the question. All right, last section here is target D, and this is when we are completing the square to solve for the vertex. So remember, our first step is to isolate what we have on one side and make sure you get rid of that constant. So the first step here is going to be subtract 6 over to the other side. So this is going to be f of x minus 6 plus some constant is going to equal x squared plus 18x plus that same constant. Alright, so now what we do is we locate that b term. I forgot my x here. We locate that b term, which is the one that has the x. So that's 18. So if I have my positive 18x, because it was a positive, I'm always going to divide it by 2. So it's going to give me a positive 9x. What I do with that answer now is I have to complete the square. We know that that positive 9x is going to be on our diagonals. I have to figure out the rest. So the x squared, that was original, right? That was part of my equation there. So the outsides are going to be x plus 9 and x plus 9, which is going to give me my c value of 9 times 9, which is a positive 81. And then when I make that a different color, so a positive 81. That's the number that we add on each side. So 81, 81. All right, now we simplify. So a -6 plus an 81. It's just asking us to determine what the c value is. I already did that, but it says find the vertex by completing the square, so we have to kind of keep going. So -6 plus 81. So we have f of x here, -6 plus 81. I'm going to go ahead and use a color just so that you know where I'm getting that from. So -6 plus an 81 is going to be a positive 75. Equals this side now, which is going to be the sides of my Punnett square box. So I'm going to go ahead and use another color here because this is whatever my perfect square trinomial is factored. So this is going to be my x plus 9 quantity squared because there was 2 of them. Remember that we have to get our f of x by itself. So I want to move this 75 over, and I'm going to do that by subtracting it over to the other side. Alright, so now my final answer here is going to be f of x is going to equal x plus 9 squared minus 75. When we state our vertex, our x value always flips its sign. So this is going to be a -9, and our k value always stays the same. So that's going to be a -75. If you need to write that for yourself, please do. Right, this was the opposite sign. This one stays the same. Just so that you remember when you state the vertex. Alright, number 21. Same steps. We want to find the vertex by completing the square. So first step is to isolate those first two terms. We have to get rid of that constant. So I'm going to go ahead and subtract 1 over to the other side. I'm going to have f of x minus that 1 plus some constant. I like to leave my space. X squared minus 16x still plus that space. I'm going to locate my b value, which was a -16. Remember, keep the sign with it. And we're always dividing it by 2. So this is going to give me a -8x. And when I do my Punnett square box, that number is what's going to be on the diagonal of my Punnett square. So that negative 8x is what I write on the diagonal. Alright, my x squared is here. The outside of my Punnett square boxes then are going to be x minus 8 and x minus 8. I figure out what my value is for actually completing my square, which is going to be negative 8 times negative 8, and that is a positive 64. Alright, adding that positive 64 over where I have those blank spaces. And I'm going to simplify each side. So I'm bringing down that f of x. I'm going to use that different color just so you guys see where I'm getting it from. That positive 1, or that negative 1 and that positive 64 is going to give me a positive 63. This is still all going to equal. Factoring that perfect square trinomial now is going to be whatever we had on the sides of our Punnett square box. So that's going to be my x minus 8 and x minus 8. There is 2 of them, so I'm going to take that binomial and square it. And now I want to isolate my f of x. So I want to get that term over to the other side, so I'm going to subtract it over. And then write my final answer and state the vertex. So f of x is going to equal x minus 8 quantity squared minus 63. My vertex from here, I'm going to state my vertex. We keep that x value, we flip the x value, so instead of writing negative 8, it is a positive 8, and the k value is always the same, so negative 63. Okay, next question here, and actually our last question on KC2 is completing the square again. So same rules as above. We want to isolate those first 2 terms. So I'm going to go ahead and subtract 16 over. That's going to give me f of x minus 16. And again, I like to leave my little space there. So x squared minus 10x plus that little space. I'm going to locate that b value, negative 10. We always cut it in half, so we're going to divide it by 2. That's going to give me negative 5x. And that is what is going to be placed on the diagonal of my Punnett square box. So I'm going to have my negative 5x here and negative 5x here. X squared, completing my outside of my Punnett square, is going to give me x minus 5 and x minus 5. When we multiply negative 5 times negative 5, that's going to be a positive 25. That's the number that completes our square and also completes our perfect square trinomial. Alright, simplifying what we got here, f of x. When we have that negative 16 plus 25, let me switch up the color here. Negative 16, oh, I don't know why I put the sign there. Negative 16 plus 25 is going to give me a positive 9. So let me change that to a plus sign. 9 equals now, that's what my sign is, the outside of my Punnett square box. So that perfect square trinomial becomes x minus 5 squared. We want to bring that positive 9 over to the right side there. So I'm going to go ahead and subtract 9. Subtract 9. And my equation is going to be over here. So f of x is going to equal x minus 5 quantity squared plus 9. Ooh, minus 9. Minus 9, minus 9, minus 9. Just undo that. Minus 9. And then state our vertex. So vertex is going to be opposite of that x value, so that's going to be a positive 5. Keep the k the same. Right, that's opposite. This one's the same. Okay, that brings us to the end of KC2. Feel free to rewatch it, look at those tests, old test reviews, old note packets. Otherwise, you can move on to KC3.